Hi, and welcome to the first section in this chapter on Terraform. For those of you who managed to put up with some or all of the rather boring content in the last basics chapter, congratulations! Terraform is the first of the real DevOps techniques we're going to be taking a look at, and one of the core tools you'll need to know to make it as a DevOps engineer. If you haven't already watched the introductory video on the homepage of this site, it might be worth heading on over there now and spending 3 minutes getting familiar with the concept of the DevOps stack. Here's a reminder of what that stack looks like. Each chapter of this site will cover a tool that's specific to one part of this stack. Mastery of all these tools will make you a formidable DevOps engineer capable of commanding some serious contract rates. Terraform is going to help us with the provisioning part of the stack, both provisioning a server and of provisioning the operating system to go on it. In fact, Terraform can provision pretty much anything you can imagine in the cloud, but at least to start with, let's just keep it simple. If you watched the section in the last chapter on spinning up a machine in AWS using the browser manually, you'll probably remember that it involved clicking on things a lot, was a bit boring and not very efficient. It also wasn't very DevOpsy for 3 important reasons. DevOps always strives to be version controlled, automated and idempotent. These concepts are to DevOps what wheat is to baking, so I'm going to say them again. Version controlled, automated and idempotent. When you're sat in an interview and someone asks you, what is it that you're passionate about in IT? Or, what do you think DevOps means? You want to have these phrases loaded into the chamber and ready to fire at a moment's notice. They are job interview gold, but more than that, they're the guiding star of all good DevOps engineers. We're going to use Terraform because it allows us to achieve each of these things when provisioning a server. So let's have a look in a bit more detail at what each of these things means. We covered version control in depth in section 3 of the basics chapter when we looked at Git. Version control means that what you are doing is in code and stored in a Git repository. There are other version control systems, mind you, but Git is overwhelmingly the most popular one, so we'll just stick with that one for now. Version control gives you a history of who did what, a unique version ID for every commit. It allows you to roll back to any previous commit, and it allows your colleagues to review your work and reject it if it doesn't meet the required standard, a process known as peer review. To me, this is probably the most important of the 3. It just can't be overstated how valuable it is to have others review your work and to have a record of that work in case you leave in a detailed list of historically ordered changes. You probably remember that it was GitHub we used to store our code in, as shown behind me here at the moment, which is by no means the only Git provider we could have used, but as one of the big players in the game I thought it was worth going for. Next, DevOps engineers like things to be automated. In an ideal world, this would be the sort of full automation whereby a single change to any part of the codebase causes various systems to magically test all of the aspects of the change before flights of angels wing it to production, a process people often call continuous delivery that we should all aim for, but in reality many businesses fall slightly short of. At the very least though, we want to aim for processes that are applied in bulk, contain no manual steps, and are never made into snowflakes. What do I mean by the concept of a snowflake? A snowflake is unique and special, it's one of a kind, and it's exactly the sort of thing we want to avoid when we're doing DevOps. Imagine a server fails at 2 AM and a hero engineer comes and swoops in and saves it with a manual change. This is the death of DevOps, because now if you spin up another server with the same template that you used for the original, it will have the same fault, and nobody knows what the manual fix was. Instead, the correct thing is to always fix the template. Every server should be identical, and you should be able to delete a server and spin it back up again without there being any problem. The last thing DevOps should be is idempotent, an unusual phrase more often applied in mathematics. The official explanation for this is denoting an element of a set which is unchanged in value when multiplied or otherwise operated on by itself. The meaning of these words slides from my mind like water from a duck though, so I'd like to propose this easily understandable definition. Something that gives the same result, no matter what you apply it to or how many times it's applied. To illustrate this idea, let's consider this glass, which contains an inch of water. If I apply the statement, add 1 inch of water to this glass, then the glass will come back with 2 inches of water in it. If I apply that statement again, it will have 3 inches, then 4, then 5, and eventually the glass would overflow. This statement is not idempotent, because the amount of water in the glass is changing, and because the amount of water in the glass after the statement is applied very much depends on how much water was there beforehand. Let's take that same glass of water again, and now consider the statement, make the glass half full. Now, if we apply this statement, the glass will come back half full. If we apply it again, it will still be half full, and further applications of the change return the glass half full every time. This statement is idempotent because it returns the same result every time. If we were to take a glass that was already almost full and apply the same statement to it, it will still come back only half full, so the starting state of the glass is not relevant. This is an important concept in Devops because you don't always know what state your infrastructure is in, but generally speaking, you always know how you want it to be. It should hopefully be clear to you then that the spinning up of servers by hand using a browser fulfills none of the above criteria, as it is accident prone, and how well you perform that process will depend on a number of factors, such as how tired you are or whether you've just been to the pub. Terraform, on the other hand, fulfills all three of these criteria. I've also chosen Terraform because, as with all the things I cover in this course, it's currently one of the best paying and most commonly requested tools on the market within the provisioning space. This is partly due to the fact it works well with both Azure, AWS, and even with Google Cloud Platform, along with a large number of other providers. In the next section, I'll demonstrate how it works, but understanding Terraform at a basic level is simple. You may be familiar with the concept of a Christmas list, a list of things a person would like, which is then sent to Santa, who provides those things for you if you have been nice. Terraform works roughly the same way as this. It is a list of things that is sent to the cloud instead of Santa, which will provide them for you in return for money rather than niceness. This is different to writing something like Python or JavaScript code, which follows a logical sequence of steps in order and has complex conditions, user inputs, and all that sort of thing. In Terraform, you write a list, and that's pretty much what you get. Simple as that. The term for the process of writing out lists of physical infrastructure like this, which can then be spun up in the cloud, is infrastructure as code. It is one of the key ways in which cloud computing has enabled DevOps to become such a powerful force in IT. Okay, I feel like I've been rambling about this quite a lot now, so let's head on over to the next section where I'll go through how to install Terraform, and I'll give an example of spinning some infrastructure up in the cloud. Hopefully see you there.